also be used to render text in images. In this section, we will see how to draw text by using the cv2.putText. So we want to use this function to write text in an image. We can use putText. Additionally, we will see all the available fonts you can use. Okay. So the function putText has the following signature. This you see cv2.putText. This is the image that we want to draw inside a text. This is a string that we want to write. org is the coordinate of the text. It means that where we want to start writing the text. Actually, when we write the text, we can imagine a rectangle around it, so it shows the bottom left of the rectangle. This is the font that we want to use. This is the font scale. This is the size of the text, size of the fonts of the text. This is the color, this is the thickness, this is the line type. Of course, let me show you from here. Yeah, here. putText. This is from documentation. This function renders the specific text string in the image. Symbols that cannot be rendered using the specific font are replaced by question marks. So there is another parameter. You know that normally the upper left corner of the image is the origin. Okay, if you want, because you should specify the coordinate of the text where the text is written, we should specify the coordinates. We put it in org. So to give the coordinates, we assume that the upper left of the image is the origin. You can say that it considers the left corner, the lower corner, the lower left corner of the image be the origin. To say that, you set bottom of origin to false. Okay? I will show you an example. I already told you that the line type can be line 4, line 8, and line AA. Line AA gives much better quality. It is an anti-aliased line type, but it is slower. So let me show you the text drawing pie. Okay. Text drawing pie. run spider. I'm waiting that the spider is running. You see here we use put text. We say that write the text in the image. This is, in this example, this is the text that we want to write. Mastering OpenCV 4 with Python. So we put a string here. These numbers are the coordinates that we want to start to write. Okay? It's 10:30. It means that column 10, row 30 start. But for the second one, we start from 10:70. For the third one, we start from 10:110. So I'm still waiting that spider runs. Ah, good. So I'm waiting that spider is running. Okay, text range. This is the code. So import CV2, NumPy, Matplotlib, show with Matplotlib. We already explained them. We have some colors. So here we create an image from zeros. This is the size, 120 to 512. It's 3 channels. Then we fill each pixel with 255. It means that all the pixels will be white. Then we call put text. You see here? Let me that I enter. So this is the image that we want to write inside. This is the text that we want to write it. It means the coordinate of the text. This is the type of the text. Okay, fonts. Hershey simplex. We have different type of fonts. I will show you. This is the scale. This is the color. This is the thickness, and this is the line type. Okay. So we write it again. So let me run it. F5. You see? Mastering OpenCV with Python. The origin of the text is here, okay? Let me show you. And may I make it bigger? You see, look here, when I put mouse on the text, you see? It's about 10:30, about, roughly. So this is the start of the text. So when you want to write a text, you can imagine a rectangle. You specify the bottom left of it. We write it again here in 10:70. We write again in 10:110. Okay, we can change these things. For example, let me show you something. For example, I put this blue. Now I run it, F5. You see, the color changed to blue. Or, for example, you can change the thickness. For example, 5. I run it again. You see, the thickness of the text changed. I press Ctrl Z. For example, you can change it to 0.5. This is the scale. I run it again. You see, it is smaller now. Okay. I can say that start from, for example, 50. So F5. You see, it goes a bit on right. Okay. So I think it's very easy and clear. Okay. I run it again. If possible, you can download the recording of the lesson. What is chirp? I don't know what is chirp. Image fill. I can write for you here. Oh, you don't have numpy, okay. NP. Of course, in the array dot fill. Fill is used to, in the array, we don't have it. Okay, anyway, fill is used to put a value to all pixels. You see, fill the array with a scalar value. Fill the array with a scalar value. When we say image.fill 255, it puts to all pixels of the image the value of 255. Okay. Okay. Let me change it again to red. Okay, that's fine. So, any question again? Why on arguments? What do you mean, Zahra? Mohsen? Why? Well, it's no problem. Maybe you mean that the image is color, okay? It's no problem. It puts to each pixel, each color 255, okay? 255, it's okay. It puts to each color RGB 255. If a pixel, each color is 255, it means that that pixel is white. Okay. You see, the background color is set to white. To perform this functionality, you can do the following. Image.fill 255. Of course, you can do this in another way. I make it a comment. You can do it like this. Of course, white. You should put each pixel to white. Okay, you can put, I don't know that we have white here or no. Yellow, black, gray, dark gray, light gray. We have white here, okay? So you can put white here, Control C, Control V. I can write here white. Okay, F5 again. So it works, you see? It works again. Or you can use another color. For example, you can put light gray. So I run it again. Then you see it's light gray. Anyway, yes, we can use another color. I told you already. So let me change it to original. Okay. All the available fonts in OpenCV are these. Font Hershey Simplex. It is equivalent to 0. Then Hershey Plain, Duplex, Complex, Triplex, and other things. So we have 8 fonts. So to show you, in connection with this, we have coded the text range fonts. Text range fonts. It's here. Okay. We put the fonts in a dictionary. 0 is this font Hershey Simplex, 1 is this, and so on. We created a dictionary. Then we have the colors here, another dictionary. Then we create an image from zeros. Then we set each pixel to white. Then we write position 1030. Then we say for I in range 0 and 8. It means that I will be 0, 1, 2, 3 until 7. Okay. Then it is written, it is printed. The I, the font, the color, we write everything. Then we call put text, image, fonts I will be one of these, okay? Fonts I will be one of these. For example, if I is 0, then the font 0 will be this string. So this is the font. Then the position, I, and other things. So if I run it, F5, you see the font, the text is the name of the font in each case. For example, when this line is font Hershey Simplex, it is written with this font. It is written with another font. So we write the name of each font using that font with different colors. I think it's not so important. We have different fonts you can use. You can use PyCharm. It's no problem for me. It's no problem for me. Okay, so in connection with this, we have coded the text-align fonts.py script, which plots all the available fonts. As all these fonts are in the 0.7 range, we can iterate and call the CV to put text function, varying the color, font, face, and org parameters. We have also plotted lowercase and uppercase versions of these fonts. The key piece of code to perform this functionality is as follows. So I explain to you this. We have, you see, lower, and of course, and upper also we should have it. This is the result. In this screenshot, you can see all available fonts in OpenCV, both in lowercase and uppercase versions. Therefore, you can use this screenshot as a reference for easily check what font you want to use in your project. So let me show you again this. So the lower, you see fonts.i. For example, fonts.0 is this string, okay? It is in uppercase. The letters are in uppercase. If you write fonts 0.lower, then you have letters in lowercase, you see? Okay. So, more function related to text. We have more functions to watch. The line 52, what do you mean? I should explain that. Okay, position. Position before the 4 position is 10, 30, okay? So, first time that the 4 is 1, we say that position, okay? So, the first text is written in this position, 10, 30, okay? Then we want to go to the 40 rows down, okay? So we change position 0. So let me show you. The position is 30 and 10 and 30. Position 0 is 10. It has 2 values. Position 1 is 30. The value of position will be 10 and 70. Okay? So each time we actually change the second part of the position. The second part is position 1, which we add each time 40. Because actually, let me run it. When we run it, the first one is written here. Then we come 40 rows down. Then 40 rows down. Each time we add to the row number 40. Is it clear? Did you understand anything, Zahra or Mohsen, about this? I'm waiting for your answer. You ask about line 52. Okay, very good. So we have other things. OpenCV provides more functions in connection. They can be used to complement the aforementioned CV2 put text function, and they are commented as follows. So the first function we are going to see is CV2 get font scale from height. The signature for this function is as follows. Get font scale from height, font scale, pixel height, and thickness. This function retains the font scale, which is a parameter to use in the CV2 put text function to achieve the provided height in pixels, and taking into account both the font type and thickness. So we want to write a text with this height, with this thickness, with this font scale, but we don't know what we should set font scale. To know it, we use get font scale from height. We give it font scale, font face, put pixel height, and the relevant thickness. Then it says to us that font scale what should be. So this function retains the font scale, considering the height, font face, and thickness. Another function that we have is get text size. So we want to write a text using a font face, using a font scale, using a thickness. Then it says us that what will be the text size, the width and height. Ali Abdul Abbas Hussein. Ali Abdul Abbas Hussein. It's not an undergraduate course. It is a master course. So you should know already the programming. You should know a lot about programming. So here we just explain part of it. It's not the first course in computer engineering bachelor. It's master. In master, we don't explain the things that you should know from undergraduate. Okay? Of course, I do my best to explain everything, but we can't actually explain step by step, line by line. It is up to you that you read them, you test them, you exercise, you practice, that you can learn everything. Okay? So I know that part of it really you don't understand at the moment, but after the lecture you can study and learn everything. You should practice. It's not an undergraduate course. It's not the first course of programming that you learn. Anyway, if you need anything, you can ask. If you have any question, you can ask. Sometimes, of course, I explain step by step, but I can't do it always. We don't have enough time to do that. So, let me text line bounding box. Let me skip this, okay? I skip these pages. So I didn't explain here, okay? From here. So I didn't explain this part, okay? So page let me close this. It seems there is a problem in showing this. So the page 200, page 200, part of it explained. Okay, let's move. So any question until now? So now we go to the next part, dynamic drawing with mouse events. Okay, we want to talk about mouse events. In this section, you will learn how to perform dynamic drawing using mouse events. We are going to see some examples in increasing order of complexity. Exam answers. You mean the scores? Or I will do it, okay? I was sick actually in these 2 weeks. Now I'm better, but not completely. So I will do that for you. I will send the answers and I also score the exam, okay? Let me explain to you. We need to set 2 dates for 2 more midterms. I already write them. We will have our second midterm on Monday, May 17 at 16:30 Tehran time. Okay. We will have another exam on Sunday, June 5 at 16:30. Okay. So remember these dates. Okay, remember these dates. I will say you until when, until where we will have an exam. So be ready for that. Okay. Because the final exam can't be more than 5 scores, so we should take 2 more exams like before. So on Monday, May 17 and June 5, we will have 2 more exams. So the next example gives you an introduction into how to handle mouse events with OpenCV. The CV2 set mouse callback function performs this functionality. Before that, I explain this. Let me run it, mouse drawing prime. So this is the mouse drawing. Okay, I run this F5. So I click here, you see? When I double click, left double click, a circle is drawn. Okay? So we say most events. When I double click, left double click, when I perform left double click, a circle at that point is drawn. Okay? I press Q to finish. Now I want to explain how we do it. Okay? Ahmed Sami Alwan, at 18 you have another course. Okay? Zahra Mohsen, you can ask about assignment. You can send a message in WhatsApp or Telegram, okay? After the class. So, you ask. So the next example gives you an introduction into how to handle most events with OpenCV. We have a function CV2 that set most callback. This function performs the functionality that helps us to handle most events. The signature for this method is as follows: set most callback. This is the window name. This is the name of a function. This function establishes the most handler for the window name. So the unmost function is the callback function, which is called when a most event is performed. For example, double click, left button down, left button up. These are the most events. So when we say most event, we mean, for example, double click, left button click, left button down, left button up. The optional param parameter is used to pass additional information to the callback function. So we need another function. We call it unmost. This is called the handler. So the first step is to create callback function. We write this function, draw circle, event xy flags param. Then I will explain to you here. So we create an image 600 by 600. Then we create a window, image mouse. Then we say that when we click something, we click on image mouse window, this function should be called draw circle. Okay? Using set most callback, we say that when we click, we do an most event on image mouse, then this function draw circle should be called. So in draw circle, we check what is the event. If the event is left button double click, so we write if event equals CV2 event left button double click. So if it is, then we call circle. What we do, draw a circle in image. The center of it will be XY. The XY will be the location of the event. So when we click on a window on a location, then the coordinate of the event will be saved into X and Y. So we say when the event is left button double click. It means that if we do left button double click, then at the location of the click, a circle with radius of 10, color magenta, field will be drawn. If the event is event mouse move, then we just print a message. If it is left button up, we print this message. If it is the left button down, we print this message. Okay? So we write first this function. This is the callback function, mouse callback function. We create an image, we create a window. We say that the mouse events on image mouse should be sent to the raw circle function. Then we write a loop. We show the image, you see, image show in image mouse, okay, in this window. In this window, we show the image that all pixels are 0. Then we wait 20 milliseconds that the user presses Q. If the user presses Q, we break, we go out from here. But if the user doesn't press Q, then and we see this picture, we click on it, we double click or click. For when we do a mouse event, then this function is called. You see, I run it again, F5. So you look here, the output. So when I move the mouse, for example, if I click, left double click, you see, a circle is drawn. If I do something else, for example, if I click once the left click, you see, look here when I click here, you see, left one click, double click, it draws a circle. If I press Q, it stops. We create window because we want to make a name for it, okay? We want to make a name for it. This is the name of the window. That's why we create it. Because we want to show this here. Of course, we can test that without this it works or no. We make this, of course, we have to do that, you know. But before that, we also should say the name of the window. But here, if we don't create the window using cv2.named window, then it may, I run it. Oh, it doesn't work, you see. If I click, it doesn't work. So, because we need the name of the window here in set mouse callback, that's why we create the window first using cv2 name window. I run it again. I'll show you here again. You see, named window creates a window. The function named window creates a window that can be used as a placeholder for images and track bars. What do you mean? When we create image but by using MP0s, it is not enough? What do you mean? I don't understand. So, let me close this one. So let me explain again everything. So the first step is to create the callback function. This is the most callback function. The draw circle function receives the specific event and the specific event, the first argument, and the coordinates x, y for every mouse event. So you see it receives event and x and y. In this case, when a left double click is performed, it means that event will be event L button double click. We draw a circle in the corresponding XY coordinates on the event. Additionally, we have also printed some messages in order to see other produced events, but we do not use them to perform any additional actions. So for other events like mouse move, left button up, left button down, we just print a message for each. So when you want to capture the mouse events, you should display the image on a window. Okay, Zahra Mohsen? So you need a window. If I understood your question correctly. The next step is to create a named window. You see, we should create a named window, a window with a name. In this case, we named it image mouse. This named window is where the mouse callback function will be associated with. So the mouse callback function is related to this window. Finally, we set or activate the mouse callback function to the function we created before. So we should say that when we click on this window, which function is called. We do this with set mouse callback. We say set mouse callback, window name, and this is the callback function. It means that if an event, a mouse event, happens on this window, the draw circle is called. In summary, when a left double click is performed, a filled magenta circle is drawn centered at the XY position of the performed double click. The full code for this example can be seen in mouse-drawing.py script. Any question yet? I think it's not very difficult. We will have another example, drawing both text and shapes. We are combining both mouse events and drawing text. In this sense, some text is rendered to show how to use the mouse events to perform specific actions. To better understand the example, in the next screenshot, you can see the rendered text. So let me first bring for you mouse drawing circles. Mouse drawing circles. I want to explain this one now. So if I press F5, run. So here a window is appeared. It says to us, double left click, add a circle. So I double left click, I click, you see, each time that I perform a double left click, a circle, a blue circle is added. If I click a right simple click, the last circle is deleted. You see, I performed a right click again, again, again. So now there is no circle to delete. So it gives a message in output. You see, no circle to delete. And then double right click, it deletes all circles. So let me click, double click left. I created some circles. Now I want to do a double right click. You see, all of them are removed. So to exit, press Q. Okay, now I want to explain this program. Now I want to explain this program. So, as I told you, you can do the following. Add a circle using the double left click. Delete the last added circle using the single left click. Delete all circles using the double right click. To perform this functionality, we create a list called circles. So we create a list where we maintain the current circles selected by the user. Additionally, we also create a backup image with the rendered text. When a mouse event is produced, we add or delete the circles from the circles list. Afterwards, when drawing, we draw only the current circles from the list. So, for example, when the user performs a simple right click, the last added circle is deleted from the list. The full code is provided here. Okay. So let me explain it. So here we have a dictionary of colors. Here we have the draw text function. It's most callback function. So we created, we set some position. Menopause is 10,500. Menopause 2, 3, 4 will be other values. So we have 4 values. Then we write the text using put text, double left click, simple right click. So these commands actually write this text. Okay, we write this text. These commands are for this. So this function that are text is for writing this text, these 4 lines in the image. Now we go to draw circles. So before that, look that we have a list here. We create a list, an empty list named circles. Circles equals open bracket, close bracket. So circles is a list. Okay. Then we create image from zeros, 600 by 600 by 3. All of them will be 0. We create a named video. We say set most callback image mouse, draw circle. Okay. Then we call draw text. We draw the text. We show the image. You see, draw the text. We call it in the image. Note that image is a global variable here, so we didn't send it here. Okay, it's a it's a global variable. Okay, so when we say there are text, the text, the 4 lines are drawn in the image. Then we create a copy of the image. So image.copy, we put it in a variable named clone. So it is the image that is just these 4 lines. Okay, nothing else. Now we create a loop. First we put clone, we make a copy of it, put it in the image, because we change image. Okay, we change image in the continue of the loop. So when we come to the first of the loop, we again put the beginning image, the image that there is no circle, just the text. We put it in the image. So we say for pause in circles. For pause in circles, for each location in the circle, we draw a circle. You see, we call circle in the image, and pause. Pause is the center of the circle. Then we show the image. So when we show the image, each time that the user clicks or performs an event, a mouse event, then the callback, this function is called circle. So we check the event. If the event is left button double click, we add XY to the list of circles. Okay? Then we double click on the image. Then we left double click here, for example here. This point has an X and a Y. So this X and Y will be appended to the list. Append, what append does? The append inserts, adds an element to our list. Circles is a list. So we add X and Y, the tuple XY to the list. So each time we click with left double click, the X and Y of it will be appended to the list. If we click right button double click, then you see this command will be executed. It makes the list empty. It means that when we draw the circles, when we say the program to draw the circles, no circle will be drawn because the list is empty. If we click right button, then it tries to remove the last element of the list using pop. Using pop, we tries to remove the last circle if there is at least one circle. But if there is no circle, then it shows this exception. It shows this message, no circle to delete. For other mouse events, we print just a message. So, in summary, what this function does, draw circle, it checks which which mouse event happens. If it is the left button double click, then it adds the location of the click to the circles list. If it is the right button double click, it removes all the values, all the numbers from the. If we perform a write click, a simple write click, then if there is at least one circle, then it removes the last one. Otherwise, it prints an error. So, in this while loop, each time we copy the initial image to image, and then using this for, we draw all the circles in the list. Actually, in the list we have some tuples. With the center of each tuple, we draw a circle. We show it again, and other things. Okay? Zahra Mohsen, you ask why we don't use CV circle after left double click event. Actually, we created a list, okay? When left double click is performed, we just add the location of the click to the list. We just update the list. But in this while, we look in the list and we draw the circles, okay? Can we erase hash and write there? Which line? Yes, you can remove these. These are comments. You can remove all lines which starts by hash. But there are some explanations, some comments. We put these comments that we know what we do. Because after a while, maybe you don't understand why you, for example, write this statement. When we want to write, when you write a statement before that, you can write a line to explain it, to comment it for yourself. You can remove it. Yes, you can remove it, but it's not a good thing. We have a program without comments.